is find the widening required in 4-lane carriageway. The length of the vehicle is given as 6 meters and the radius of the curve is 300 meters and the speed of the vehicle is given as 50 km/h. So extra widening, we know that extra widening is equal to xl square by 2r plus point or nn square by 2r plus 0.1 v by root r. So by substituting the values of number of lanes, n is equal to 4 and length of the vehicle 6 meters and radius of the curve is 300 meters and the speed of the vehicle is 50 km/h, we will get the value by substituting these values in the equation 1. We will get the value of the extra widening as 0.53 meters. So option A is correct. The question is, the radius of horizontal curve is 90 meters and the design speed is given as 50 km/h. The coefficient of lateral friction is given as 0.15. Calculate the super elevation if full lateral friction is called into play. So the full lateral friction has to be considered according to the statement. So E plus F is equal to V square by 127 R, where V is in km/h we know. By substituting the values from the above data, we will get E super elevation is equal to 0.07. So option C is correct. It is a direct question. The greatest gauge of long rivet should not exceed 8D. So option D is correct. Question is, the safe load P of the fillet welded joint shown in the figure can carry if the shear stress through the throat of 8 mm weld does not exceed 100 Newton per millimeter square. So from this figure we come to know that effective length is equal to 110 plus 110 plus 110, that is equal to 330 mm. Okay, throat thickness T is given as 8 mm. So effective throat thickness is going to be 0.7 times the 8 mm, that is 5.6 millimeters as per IS. So the safe load is equal to P into L into T. P is equal to 100 Newton per millimeter square. Effective length is 330 into thickness is 5.6. That is equal to 18,480 newtons. That is equal to 18,480 kgs. So option 18480, option B is correct. Question is, a cohesive soil has an angle of internal friction phi is given as 15 degrees and the cohesion is given as 35 kilonewton per square meter. If the specimen of this soil subjected to a triaxial compression test, find the value of lateral pressure in the cell for a failure to occur at a total stress is given as 300 kilonewton per square meter and we have to find out the lateral stress, that is sigma 3. So we know the equation sigma 1 is equal to sigma 3 tan square 45 plus 5 by 2 plus 2c tan 45 plus 5 by 2. So we know that phi is given as 15 degrees and c is given as 35 kilonewton per square meter and sigma 1 is 300 kilonewton per square meter. So by substituting these values in this equation 1, we will get sigma 3 is equal to 122.92 kilonewton per square meter. So option A is correct. In a vane shear test of clay, the following observations were made. So the weight is the data collected from the vane shear test. Applied torque is about 183 centimeters and the height of the vane is 10 centimeters and the diameter of the vane is 5 centimeters. We have to calculate the shear strength. There is a relationship for the torque and shear strength. So shear strength is equal to torque divided by pi d square into h by 2 plus d by 6. So by substituting the values from the above data in this equation 1, we will get 0.4 kg per centimeter square. So option D is correct. The question is, using Rankine formula, find the minimum depth of foundation of a square footing 1 meter by 1 meter. Area is given as 1 by 1, that is 1 square meter of the column carrying a load of 15 tons. So the load of 15 tons is acting, including the self weight. The foundation consists of cohesionless soil. So C is 0. Unit weight of soil is given as 1.85 pound per cubic meter with the shear angle of internal friction is given as 35 degrees. So we know that by using Rankine's formula, the depth of foundation is equal to Q by gamma into 1 minus sine phi by 1 plus sine phi whole square. So here Q is equal to load Q divided by area, that is 15 tons by 1, that is 15 tons per square meter. So gamma we know the unit weight, so 15 divided by 1.85 into 1 minus sine 35 by 1 plus sine 35 whole square, that is equal to 0.595 meters. 0.595 meters is option B is correct. Please determine the value of critical hydraulic gradient for a loose deposit of sand having void ratio of 0.67 and specific gravity of 2.7 is given. So the hydraulic gradient corresponding to the quicksand condition, which gives the critical hydraulic gradient. So we know that critical hydraulic gradient is equal to G minus 1 by 1 plus E. G minus 1. G is specific gravity minus 1 by 1 plus 0.67. So the critical hydraulic gradient is 1.02. 1.02. Option D is correct. So the question is specific energy of a flowing fluid per unit weight is given by. We know that total energy per unit weight is Z plus H plus V square by 2Z. So the specific energy is V square by 2Z plus H. So option C is correct. So the question is the velocity of flow at critical depth Hc is called critical velocity, which is equal to, at the critical depth, what is the critical velocity equation? Vc is equal to root g Hc. So option B is correct. Is find the diameter of an open well to give the discharge of 3 liters per second. The depression head is 3 meters and the specific yield is given as 1 meter cube per hour per square meter. So Q discharge is equal to K into H, that is K by A into H. We know the discharge Q is equal to 3 liters per second, that is 10.8 meter cube per hour, that is K by A is equal to 1 cubic specific yield hour per square meter. So by substituting these values in the above equation, we will get equation 1, Q is equal to 10.8 is equal to 1 K by A into pi by 4 D square into H is 3 meters. Therefore, D is equal to 2.14 meter. 2.14 meter, option A is correct.